Not realizing that the water that's rushing past you can power an entire town.
Today, you will be building a 1.2 gigawatt hydroelectric power plant.
Hydroelectric power is amazing because we all need electricity, but this just harnesses water. Water at an altitude flowing to water at a lower altitude, and the only waste product is water.
Makes me feel a little bit better plugging in my phone so much.
You will need a raging river, 21.6 billion pounds of concrete, 8 penstock tubes, 8 turbines, 8 generators, and an electrical appliance of your choice. Step 1. Dam that river.
Well, in order to get power from a flowing body of water, first you have to actually harness that water.
Traditionally, dams were built by diverting a river and then building the dam in its place and then bringing the water back. But nowadays, they can actually build the dam straight in the river's pathway, and that's called building in the wet.
Build a construction site on the bank of your river. Use the site to fabricate concrete sections. Lower the completed sections into the water with barges and cranes. Use divers to attach them to underwater foundational piers.
Once you've completed the dam, then you let the water build up behind the dam, and the potential energy of the water at the top of the dam is enormous. Okay, so how do we convert this potential energy into electrical energy? The dam just uses the falling water.
Step 2. Send your falling water through pipes.
In a hydroelectric power plant, a penstock is actually the tube that delivers the water from the river down to the bottom.
All that water with all that potential energy is funneled through this pipe, so you need a good quality pipe.
Install 8 30-foot diameter steel penstocks, A, leading from the face of your dam, B. Now you just need a way to steal that water's energy. For that, we recommend a power station full of turbines. Step 3. Add gigantic turbines.
So when water is rushing past, that is a lot of potential energy that's just whoosh, kind of lost. It's like a wild horse. And so what the turbine does is it makes use of that energy.
A turbine is a machine with a turning rotor that converts moving fluid to mechanical power.
There are a couple of different types of turbines.
I'm excited about this because there's the Francis and the Pelton. They're a little different.
Well, there's the Francis turbine, and you can think of a pinwheel that you turned on its side. It's spinning horizontally. The other type of turbine is a Pelton turbine, and it's a vertically spinning wheel.
So what kind of turbine are you going to use in your dam? Well, it depends on the height difference between the reservoir and the river. So if you don't have a huge height difference and you're really harnessing the flow of the river going horizontally, you might want to go with a Francis turbine that spins on the same axis. But if you're using the height difference as your advantage, an impact turbine like a Pelton would be good if you've got the water falling at a great distance, because that force is going to spin the wheel perpendicular to the axis of the river a little bit harder. Hopefully not a lot of fish are disrupted in the process. You eat your worms, or you're going to the turbine.
In case your dam has a large elevation change, you may want to opt for a Pelton turbine. Attach 8 turbines, A, so that the nozzles at the ends of all 8 penstocks, B, fire water squarely at their buckets, C. The turbine should spin. Now all you need to do is turn that rotation into electrical power. Step 4. Let's generate some electricity.
Now, the way generators work is when you move a metal wire through a magnetic field, it generates an electric current in that wire. In a hydroelectric power plant, we use the movement of the water to power some turbines which spin around to turn those wires through that field. And that generates a whole load of electric current that then gets sent off to the power grid.
Open the gates to your penstocks, allowing water to rush through your turbines. Spin the wire coils in your generators and send the resulting electrical power across the land.
The power is sent through to your house, and then it gets sent through to your TV, which is how you're watching me right now.
A 100 megawatt power plant can generate enough power to run an entire city, but the process can also work on a smaller scale.
My dad is a tree farmer on Kauai, and he actually built a hydroelectric power plant on his property using the power from water flowing from a reservoir right on the land. 10 houses on Kauai are using the power provided by my dad's power plant. He's gonna be so happy I'm talking about him.
Finally, celebrate your finished power plant by putting some of that electricity to good use. But remember, don't overload your circuit.